In question 4, we have to find the square roots of the following numbers by the prime factorization method. So for each number, we have to first prime factorize it, and then we have to use that prime factorized form to find its square root. So let's start with the first number. The first number is 729. Now 729 is not divisible by 2, but it is divisible by 3. So our first factor is 3. So 729 divided by 3 is 243, and then this is again divisible by 3. So 243 divided by 3 is 81. 81 is again divisible by 3. So we take out another 3 and we get 27. 27 is yet again divisible by 3. So we get we take out a 3 again from 27, and this will give us a 9. And we can take out one more 3. And that gives us a 3, and finally we can take out a 3 and we'll be left with a 1. So the prime factors of 79 are 3, 3, 3, 3, 3 and 3. So 3 is repeated 6 times. So we can write 729 as 3 into 3 into 3 into 3 into 3 into 3. So 3 repeated 6 times, and we can, if we split it into pairs like this, we can see that 729 can be written as 3 into 3 into 3 square. So the square root of 729, can be written as 3 into 3 into 3, the term inside the bracket that we've written here. So 3 into 3 into 3 is 27. So the root of 729 is 27. That's the answer for the first part. In the second part, the number is 400. And 400 we see is divisible by 2. So let's start dividing it by 2. So 400 by 2 is 200. Then 200 is still divisible by 2. So we take out another 2 and this gives us 100. 100 is still divisible by 2. So we take out 2 again. This gives us 50. And we take out another 2. This gives us 25. Now 25 is not divisible by 2 or 3, but it is divisible by 5. So we take out a 5. And that leaves us with this 5. We take it out and we're left with 1. So this number 400 can be written as 2 repeated 4 times. So 2 into 2 into 2 into 2, and then 5 repeated 2 times. So if we split it into pairs, we'll have 2 into 2, another 2 into 2, and then we will have 5 into 5. So we can write this as 2 into 2 into 5 whole square. So the root of 400 will be this term inside the bracket, which is 2 into 2 into 5. That's 4 into 5 or 20. So the square root of 400 is 20. In part 3, the number is 1764. 1764. This is an even number, so we can start the prime factorization process by dividing this by 2. So 2 is our first prime factor, and that will leave us with 882. This is still even, so we divide by 2 again, and this gives us 441. Now this is not even, but if we add the digits of 441, that gives us 9, and this means that this is divisible by 3. So we divide 441 by 3, and that will give us 147. And 147 is still divisible by 3. So we divide this by 3, and that gives us 49. And now 49 is not divisible by 3. It is also not divisible by 5, but it is divisible by 7. So we get 7, and we are left with 7. And we take out this last 7, and that leaves us with 1. So 1764 can be prime factorized as 2 into 2 into 3 into 3 into 7 into 7. So if we split this into pairs, we have 2 into 2, we have 3 into 3, and we have 7 into 7. So we can write this as 2 into 3 into 7 whole square. So the square root of 1764 will be this expression inside the bracket, 2 into 3 into 7. So it will be 2 into 3 into 7, and this is equal to 6 into 7 or 42. So the square root of the third number is 42. Now let's do part 4. In part 4 the number is 4096 and this is an even number, so we will start dividing by 2. So we divide by 2 and this gives us 2048. Again even, so again we divide by 2, so this gives us 1024. This is even again, so we divide by 2 again and this gives us now 512. Still even, so we divide by 2 again and this gives us 256. And even yet again, so we divide by 2 again and that gives us 128. And 128 is again even, so we divide by 2 and that gives us 64. So I'm going to write out the remaining part here. So 64, and we take out 64 is even, so we take out 2 again and that gives us 32. And from 32 we take out 2 again, so that gives us 16. And from 16 we take out 2 again, so that gives us 8. And take out 2 again, that gives us 4. Take out 2 again, that gives us 2. And take out the last 2, that gives us 1. So 4096 is made up completely of factors of 2. So it is a perfect power of 2. And how many 2's are there? So let's write out. We have 1, 2, 3, 4, 5, 6 2's here, and then we have 7, 8, 9, 10, 11 and 12. So in all we have a total of 12 2's, and if we split them up into pairs we will have 6 pairs of 2's. So I can write 4096 as 2 into 2 into 2 into 2 into 2 into 2 6 times, and then take the square of this. So this is how I can write 4096, and this basically means that the square root of 4096 will be the term inside this bracket. So 2 multiplied by itself 6 times, 2 into 2 into 2 into 2 into 2 into 2, so that's 2 raised to the power 6, and this will be equal to 64. So the square root of 4096 is 64. Now let's do part 5. In part 5 the number is 7744 and this is an even number. So we will start the prime factorization process with 2. So divide this by 2 and that will give us 3872. Now this is still even, so we divide by 2 again and that gives us 1936. So this is even yet again, so we divide this by 2 and that will give us 968. All right, and this is still even, so we divide by 2 again and this will give us 484. And again even, so we divide by 2 again, so this time it gives us 242, and this is still even, so I divide by 2 again and this gives me 121. And we know that 121 is the square of 11, so we take out 11 and that leaves us with 111, and then we take out another 11 and that leaves us with 1, and that completes the prime factorization process. So 7744 can be prime factorized as 2 into 2 into 2 into 2 into 2 into 2, so that's 6 2's, and then 11 into 11. So if we split this up into pairs, we have 1 pair of 2's, 1 pair of 2's, 1 pair of 2's, so total 3 pair of 2's, and then 1 pair of 11. So we can write this as 2 into 2 into 2 into 11 and the whole square of this thing, right? And this means that the square root of 7744 will be the term inside the bracket, and this is equal to 2 into 2 into 11 into 2 into 11, and that is equal to how much is this equal to? 2 into 2 is 4, 4 into 2 is 8, 8 into 11 is 88. So the square root of 7744 is 88. That's the answer for part 5. Now in part 6, let's do part 6. In part 6 the number is 9604 and this is an even number. So we can start dividing by 2. So we divide by 2 and that gives us 4802. Still even, so we divide by 2 again. So this gives us 2401. Now what do we divide this by? So this is not divisible by 2. It is not divisible by 3 also, because the sum of digits is not divisible by 3. It is not divisible by 5, but if you check, it is divisible by 7. So if you divide this number by 7, you will get 343. This is what you will get if you divide this number by 7, and you divide by 7 again, and this will give you 49, and this is still divisible by 7, so we get 7 now, and finally one more 7 we take out and we left with 1. So this completes the prime factorization process. So 9604 can be prime factorized as 2 into 2 into 7 into 7 into 7 into 7. So 7 is coming 4 times, and if we split this into pairs, we have a pair of 2, we have one pair of 7, and we have another pair of 7. So I can write this as 2 into 7 into 7 whole square. And now the square root is straightforward to write. So the square root of 9604 will be this product inside the bracket. So this is 2 into 7 into 7, and this is 2 into 7 is 14. 14 into 7 is 98. So the square root of 9604 is equal to 98. That is the answer for part 6. In part 7, we have the number 5929. This number is not even, so not divisible by 2. The sum of the digits of this number is 5 plus 9 14 plus 2 16 and 9 25. So this 25 is not divisible by 3. So this number is also not divisible by 3. It's also not divisible by 5 because the last digit is 9. But if you check, it is divisible by 7. So we will start the prime factorization process with 7. So dividing this number by 7 will give us 847, and this number is again divisible by 7. So if we divide 847 by 7, we will get 121. And now we immediately see that 121 is the square of 11. So we can divide this by 11. So we get 111 left, and then we take out this 11 as well. So we are left with only 1. So 5929 can be prime factorized as 7 into 7 into 11 into 11. And if we split this into pairs, we have a pair of 7 and a pair of 11. So we can write this as 7 into 11 whole square. And this means that the square of 5900, the square root of 5929 can be written as 7 into 11, the product inside the bracket, and this is equal to 77. So the square root of the numbers in part 7, 5929, is 77. Now let's come to part 8. In part 8, the number is 9216, and this number is, the ending digit of this number is 6. So this number is clearly divisible by 2. So we start dividing this by 2 and divide this by 2. That will give us 4608. Again divisible by 2. So divide by 2, and that gives us 2304. This is again divisible by 2. So we divide this by 2, and that gives us 1152. Again this is divisible by 2. So we divide this by 2, and that gives us 1152 divided by 2 will be 576. Divide this by 2 again, and that will give us 288. This is again divisible by 2, so that gives us 144. And now let me continue this process here. So 144 again divisible by 2, so we divide this by 2, and that gives us 72. Divide by 2 again gives us 36. Divide by 2 again gives us 18. Divide by 2 again gives us 9. Okay, now we can't divide by 2 anymore, so we divide by 3, and that gives us 3. And finally we divide by 3 once again, and that gives us 1. So that completes the prime factorization process, and we see that 9216 can be prime factorized as how many 2's? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 2's in all, and there are 2 3's. So what I can do is I can write 9216 as 5 2s. So take 5 2s and then take 1 3 and then put a square around this. So you will get a total of 10 2s and 2 3s. So this means that the root of 9216, if you take the square root now, the square root of 9216 will be this product inside the bracket. So this is 2 into 2 into 2 into 2 into 2. So 2 repeated 5 times and then 3. And how much is this equal to? So 2 repeated 5 times is 32. 32 into 3 is 96. So the square root of this number in part 8, 9216, is 96. In part 9, we have the number 529. Now 529 is not even, so it's not divisible by 2. It's also not divisible by 3 because the sum of digits of this number is 5 plus 2 plus 9, that's 16, which is not divisible by 3. It's also not divisible by 5, and we can check that it's also not divisible by 7. Also, it's not divisible by 11 because if you take the alternating sum of digits, so if you take 5 and 9, that's 14, and subtract 2, that's 12, so you don't get a multiple of 11. So it's not divisible by 11 either. It's not divisible by 13 either because if you divide 529 by 13, you will get a remainder of 9. And it's not divisible by 17 either. So it is not divisible by any of these prime numbers, but let's keep moving forward. So let's take the next prime number, which is 19. If you divide 529 by 19, you will see that it's not divisible by 19 either. But the next prime number is 23. And if we divide 529 by 23, let's see what we get. So 52 by 23, so 23 times 2 is 46, and the difference of 52 and 46 is 6, so we get 69 as our dividend, and 69 by 23 is 3. So 529 is exactly divisible by 23, and in fact 529 is 23 into 23. So it has only this prime factor of 23 repeated twice, and that is why it was not divisible by any of these previous prime numbers from 2 up to 19. So 529 is 23 into 23 or 23 square, and this immediately gives us the square root of 529. The square root of 529 will be equal to 23. So that is the answer for part 9. The square root of 529 is 23. Now last, let's do part 10, which is the number 8100. So this is even because the ending digit is 0. So let's start dividing this by 2. So 8100 by 2 will be 4050. Finally, let's do part 10. In part 10, the number is 8100 and this is even because the ending digit is 0. So let's divide it by 2. So if we divide it by 2, we will get 4050. Still even, so we divide by 2 again. So this gives us 2025. This is not even anymore, but if you sum the digits of this number, the sum is 9. So this number is divisible by 3. So we divide this by 3 and that will give us 675. Again, this is divisible by 3. So if we divide it by 3, we will get 225. This is again divisible by 3 because the sum of digits is still 9. So if we divide by 3, we will get 75, and this is divisible by 3 as well. So divide with this by 3 and that gives us 25. And now 25 is divisible by 5, the next prime factor. So we have 5 left and then we take out the last 5 and we are left with 1. So this number 8100 can be prime factorized as follows. So we have a pair of 2, then we have 4 3s, so we can split it up into 2 pairs of 3s. So we have 3 into 3, and then we have another 3 into 3, and then we have 5 into 5, right? So we can write this as 2 into 3 into 3 into 5 and the square of this product. So this is 8100 in prime factorized form. So if we now take the square root of 8100, it will simply be the product inside this bracket. So this is equal to 2 into 3 into 3 into 5, and this is equal to 2 into 3 is 6, 6 into 3 is 18, 18 into 5 is 90. So the square root of 8100 is 90. That's the answer for part 10. And with this we have completed all the parts of question number 4.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.